Welcome. This is John Mitchell, and I'm one of the Java instructors at Lambda School. And as we can see, my machine has decided not to show you my screen, and now I've got to figure out why. Okay. That is really bizarre. So, a small technical difficulty. Let me get this finished and let's see what we can do about it. All right, hang on. Hang on. I do apologize, people. This is working out so well. As always, right? It works out so well in the sample. Oh my goodness. Well, okay. That works for me. Okay. So, thank you for your patience while I get this set up. This is my first time. Obviously, you could probably tell really quick that this is my first time to be presenting on YouTube Live. So, let's see if we are working now. All right. So, what all right. Okay. So I'm going to get started. We should be in good shape now. For those of you that are brand new to Java, that is great. That is where I'm assuming with my presentation. So the title of this is Getting Started with Java for Backend. My name is John Mitchell, and I am one of the Java instructors here at Lambda School. And what I want to do today is I want to talk about Java. So yes, it's getting started with Java for back-end development. But the key word here is Java. And so let me just talk about Java for a minute. So why in the world would we want to learn Java? Well, one of the things is there's arguably more lines of code written in Java than in any other programming language that is out there. There's over 3 million devices that run Java. When we start talking about the Java programming language, we have to remember that a lot of our devices out there, our Internet of Things, actually run Java. So we're looking at medical monitoring equipment, we're looking at satellites, we're looking at your cars, we're looking at your programmable toasters. I have a friend that has a wine bottle that actually he has gotten Java to run on, all sorts of things. And there's a lot of people out there that understand Java code because it's a really popular introductory language. So there's a lot of people out there that know Java code. They might not be proficient with it. They may not be Java developers, but it's a really good language to know. So just a brief history. This all got started in 1996. I've been working with Java from day one, from version 1. We are now at version 16, was just recently released. Most of the things that we do are written with version either 8 or 11. 11 is Java's latest long-term supported version. 11 is the version that I normally use. interesting thing about Java, so you don't get confused with this, there is no difference between, there is really no connection between Java and JavaScript. They share four letters. Just like, the school that I teach at is called Lambda School. Well, Lamb is to Lambda School, just like Java is to JavaScript. There's really no relation between the two. So just keep that in mind, that it's a very unfortunate naming convention. So Java, there's a couple of things you should note about Java. First of all, a lot of you, when we start looking at actual Java code, which we're going to get to in just a minute, it's going to look a lot like other programming languages that you've used. That's by design. When they first came out with Java, one of the things that they wanted to do was to make it similar to other popular languages, which at the time was C++. So we have the full C line that Java looks like. But the big thing about Java is Java will come in and develop, when we create Java, we're going to compile it to this intermediate code that's called bytecode. And it's that bytecode then that we're going to ship around to our different devices. And the really nice thing is I can be sitting here using my Macintosh developing Java, compile it to this bytecode that then I could send to my refrigerator, and it would run on my refrigerator if my refrigerator ran Java. So the device, it's completely independent of the device you're going to run it on. And the reason behind this is because of this idea of the Java virtual machine. Now, most of us, if we have installed Java on our machine, we've installed this thing called the Java virtual machine. And what the Java virtual machine does is it takes that bytecode and it converts it to something that works on your computer. That's the whole point behind it. So with the Java virtual machine, that's what gets installed on your satellites, on your cars, on your wine bottles to run this bytecode that we're working with. Now, on machines that have enough resources, like your personal computers, we also install, along with the what's called the JVM, the Java Virtual Machine, we also install this thing called a JRE, a Java Runtime Environment. And again, that's just a collection of other modules that assist the JVM in executing Java. Now, if you want to take it the next level up, so this JRE and JVM are the things that you have to have installed on your personal computer to run Minecraft, say, to run some Java application. And if you want to take that up to the next level where you're developing Java applications, which is what we want to do, you're going to have installed what's called the Java Development Kit. And so that includes an additional set of modules that allow us to actually develop Java. And one more thing I want to talk about with Java is that when Java got started, and one of the things that makes it such a nice language to use, especially when we're talking about back-end development, and we'll talk a little bit more about back-end development as we go along, what we mean by that. But so when Java first came out, one of the ideas was that they wanted it to be familiar, which we just mentioned, modeling like the C#, C++ languages. Definitely wanted it to be object-oriented. When it came out in '96, that was kind of an emerging paradigm in programming that has really taken off. And we'll talk about what that means in our sample code in just a minute. They wanted it to have security and robustness built into the language itself. And that was one of the problems we have with some other languages, is that Java, especially because of this virtual machine, you don't have, if something happens with your Java application, you can restart that virtual machine and leave the underlying host, the underlying server running. So Java kind of isolates itself into its own environment, and that just makes it a whole lot more secure, and it prevents it from really affecting the rest of the architecture, the rest of the enterprise. So that makes it really nice for enterprise-wide systems. So if there's a fault with the Java app, it's with the Java app and not with the enterprise-wide structure. Also, we wanted it to be architecture neutral. We wanted it to be portable. So we don't care if you're going to run it on a Mac, on a Windows, on a Linux machine, if you want to run it on a supercomputer, if you want to run it on an IBM mainframe. We don't care. We developed the same way. And then we also wanted to build into it from the beginning to have it be a threaded language, meaning that it can take advantage of multiple processors, multiple CPUs, these sorts of things. So that's kind of where we're headed with Java. So with the back-end system, what we talk about is things that really affect the foundation and affect the enterprise of the company. And so things like this number 2, where it's robust and secure, incredibly important inside of a large company. You don't want your system to affect others. This idea of being architect neutral, you don't want your choice of programming language then to dictate what hardware you can bring in. So really a nice choice for an enterprise-wide development language. Well, I've been talking enough about Java. Let's actually see some Java in action. I am going to be using a development environment called BlueJ. And now you'll see me pause for a second while I load up BlueJ. Okay. Okay, so this, and it's bluej.org, is where you could download this environment. And when we talk about developing in Java, there's a lot of different types of IDEs, integrated development environments, that you can use. I happen to pick BlueJ. BlueJ is very easy to install on just about any desktop computer. It's really good for getting a feel for the language and how to work with the language. It's free. That's always a nice thing. There are some others out there, though, that are a little more robust IDEs, but they do more for you. So they're probably not a good way to introduce the language, but BlueJ is going to do a great job for what we want to do. And what we're going to do today is I'm going to take you through a simplistic tic-tac-toe game. While we're doing that, I'm going to talk about how that could be tied in with some back-end systems. But what I really want to do is not so much in developing the game is not as important as showing you some of the syntax, some of the possibilities, some of the things that you can do using the Java language. So what I'm hoping we get out of at the end of this presentation is that you'll see why Java is something you would want to learn. That's kind of what I'm hoping to get at, and hopefully this gives you a little bit of a way to get started with Java. All right, so I have started this BlueJ project here. Actually, I'm going to create a new project. So what I'm going to do is I'm going to come up and create a new project, and you can think of this as creating a new application. And I'm just going to call it tic-tac-toe. It sounds like a good name for it. Now, this is something from the BlueJ system. They provide this README file that you could come in and fill in about the application and explain a little more about the project. So that's what that file is. Java is an object-oriented language. What that means is we are going to create a series of what are called classes. Classes are, you can think of those as like the blueprints, or the factories, the prototypes of what we're going to be looking at, what we want to use in our system. So the first thing we do when we go to attack a object-oriented application, which is what this is going to be, is we think of what's involved in our application. What are some of the actors, some of the characters that go into our application? In other words, another way to look at this is, what are some of the nouns that our application is going to need to use? So what are some of the things, the characters that go in with our application? Well, when I think of a tic-tac-toe game, the first thing that pops up into my head is a board. We need a game board to actually play on. So I'm going to create a class that I'm going to call board. I'm going to need one of these things, and in a minute I'm going to go in and I'm going to work on what actually goes on with the board. But to begin with, I need a board to play on. And this is kind of the way you think through object-oriented languages. Really, Java and C# are the two big object-oriented languages that are out there right now. And by the way, a little bit of a tip on C# and Java. They're basically the same. The syntax is very similar. If you learn one, switching over to the other is really easy to do. So personally, I think learning Java is the way to go and then picking up C# later. But, switching over between those two is fine. So, object-oriented. We decided we needed a board. Another thing that we need is we need a player, right? There's going to be actually two players, but we need a player. That kind of makes sense. Another thing, I'm going to line up these little pictures just so they'll be lined up. The other thing that we need is our players then are going to have to be able to have pieces that they're going to put on the board. And I'm just going to call these pieces. The names, you could pick whatever you want. I'm just going to call these pieces. I just like calling them that. And one more thing that every Java application has to have is an entry point. And every Java application out there, whether it's running on your toaster, on your supercomputer, on your medical device in the hospital, they all have an entry point, a place they get started. So I'm going to create one of those. And by tradition, we call it main. We could call it anything that we want, but by tradition, we call it main. So these are kind of like I said, these are the actors. These are the things that we're going to be using to interact with our tic-tac-toe game. We have a place to get started. We have a board to play on. We have players that are going to play. And then we have pieces that the players can use to make their plays. Great. Well, let's just look at the board to begin with. So I'm going to come in here to this board class, and I'm going to make some things in here. Now, BlueJ, by default, puts in a bunch of stuff here to kind of help you get started. I find it confusing, so I am going to delete it. All right. So what do we know about a board? So when we're working with tic-tac-toe, there's a few things that the board has to keep track of. So what's important about the board? Well, one of the things the board needs to know is the board needs to know its size. And that makes sense that the board is the one that's going to know its size. So what I'm going to do is I'm going to come in here and create what is called an instance variable. One of the things you'll quickly notice about Java is that there are these things called access modifiers. Public means that anyone in the application can make use of it. Private means that only the class knows about it. So I'm going to say that only the board needs to know how many rows it has. Only the board needs to know how many columns it has. Well, that's not completely true. Sometimes other objects, sometimes other objects, maybe this main needs to know the size of the board, or maybe pieces needs to know if they can be put at a certain spot. I don't know. There might be some other play times where these other classes need to know about the size of the board. Well, what we don't do is we don't allow just anybody to go up and read the mind of the board. Give you an analogy here. Obviously, I have a phone, right? And I have a phone number. Well, I don't think it's right that you would come up and read my mind and get my phone number. You should have to come up and ask me, and then I can decide whether I give you my phone number or not, or whether I warn you that if you really want to get in touch with me, you better text me as opposed to call. But I'm in control over who gets my information. And we do that in Java using something called getters. So instead of allowing people to just come in and read our minds, people allowing the other objects to come in and read our minds, I'm going to force them to go through these things called setters. They're going to have to ask me for the information. You'll notice one thing immediately about my coding style. Really common nowadays is to put the opening brace at the end of the previous line. So any chunk of code, any block of code here requires these braces. And one of the things I like about BlueJ is that it color codes it for us. Well, that's great. There's nothing wrong with that. Like I said, I've been around Java since the beginning. And when we first started working with Java, we put our opening brace on their own line. And that's just been a habit that I've got. I really like the way it gets lined up so I can see exactly where these things go together. But in the end, it comes down to personal preference. All right, if we're going to have one of these for rows, we probably want to have one of these for columns. So what I'm doing here is I'm creating what is called a method. This is actually a specific type of method called a getter, but these are methods. These are things that the board can do. One of the things the board can do is it can tell people what its max row or what its max columns are. So these are things these are behaviors that the board has. These are things that the board knows. And you'll notice that I have some red squiggly lines. That'll happen as I go through here. We're going to fix those in just a minute. All right. Another thing that the board needs to know is it needs to keep track of the pieces that are on the board. And so I'm going to create what's called a two-dimensional array. It's a data type, a data structure that Java supports. And what it allows me to do is it allows me to develop the familiar rows and columns that we know about with the tic-tac-toe game. So let's do this. What I want to do is I want to create a tic-tac-toe game, and I'm going to, in each one of the little spots on a tic-tac-toe board, I could put a piece. And I'm just going to call this the game board. So in each one of my little spots on a tic-tac-toe board, I'm going to be able to place a piece there. At least one, right? I mean, that's hopefully no more than one. And we're going to be able then to play this way by putting pieces on this game board. And remember, a piece is right here. We don't know much about a piece right now. We're going to get to that. But it's going to be able to take one of these pieces that's going to be owned by a player. So one of these pieces, and we're going to be able to put it on our game board. And the board itself is going to keep up with which piece is where on the game board. In Java, we don't actually do any work on these classes. These classes that we're setting up right here, at least these three, this one's special because it's our entry point. But in these three classes right here, we don't actually use the classes directly to do work. What we do is we create what is called an object of the class, which what that does is in practice is I can have as many boards, so as many different game boards going on at a time as I want. And remember we said that Java was a multi-threaded language. What that means is I could set this up. We're not going to be able to get to that today, but I could set this up so I have multiple tic-tac-toe games running at the exact same time using this one class. And we're going to talk about how that happens in just a minute. But what we need to do is we need to be able to create a board. So it's called instantiating an object. We're going to create an instance of the class board. So we need to be able to create one of these. So let's do this. The way we do that is through a special method, a special behavior that's called a constructor. And it allows us to construct, to create an object of type board. What I'm going to do is when I create this board, I'm going to create it by telling it how many rows and how many columns it's going to have. So normally it'll be a 3x3, right? But if we wanted to make it a 4x4 or a 5x5, we could. Nothing in the code I'm writing prevents us from having weird board sizes. What I need to, so I'm going to send it as what are called parameters. I'm going to send it this information, and I'm going to say, hey, set up my board using this information. Okay. So I'm just going to take this max. Oops. So I'm going to take that information that got sent to me, and I'm going to use it to set up the maximum rows and the maximum columns. And then I'm also going to use that information to set up my game board. And my game board, remember, is pieces. It's going to be made up of pieces. But how many pieces? Well, in my rows, there's going to be max rows. And in my columns, there's going to be max columns. So we now have a basic board set up, and we have a way to get the maximum rows, the maximum columns. There's several things, of course, we're still missing, but one of the big things that I think we'll need to do is we need to be able to print a board. So we need to have some way to print this board, this game board that we have right here. How do we want to display that to the screen? How do we want people to let our players know what the game board looks like? Well, here's what we're going to do. I'm going to come down here and create another behavior. Now, this behavior allowed us to get an integer. This behavior allowed us to get an integer. This behavior is not going to allow us to get anything. It's just going to display something on the screen. So I have to put something here. Some sort of data type has to go here. That's required by Java. So I'm going to use void because there's really nothing to do there, but I have to put something there. So I'm going to put void. What I want to be able to do is I want to be able to print a board. Well, one thing that I could do is I could just come in here and I could print the players. Well, the problem with that is, by the way, in Java, every statement has to end with a semicolon. Now, the trick is then figuring out what's a statement, right? And so, but if you have a statement, it's got to end with a semicolon. And that's what that problem was right there. Before I go to print my board, I want to spend a couple of minutes looking at what we mean by a piece. So we have this board that is placing a piece on the board. And I want to spend a minute talking about what we mean by a piece. What goes involved with a piece? All right, let's go take a look at that for a second. So we're going to have this game board that's made up of pieces. Now, right now, pieces doesn't have anything in it. Well, pieces are actually going to be tied to a player. So let's work with player first. So I'm going to come over here to player. And again, I'm just going to come in here to player and I'm going to get rid of all of this mess. I don't want any of this. Now, a player, for right now, the only thing that a player's going to know is its name. I mean, we could come back in later and add like the score and stuff like that to it if we wanted to. But for this example, a player is just going to know its name. And I'm just going to allow my names to be a single character. So like X and Y. Again, it's private because I don't want just anybody to be able to figure out the player name. The player should be in control of that. Final means that once I set the player's name, once I give it a name, I can't change it. Which makes sense. You wouldn't want in the middle of the game for Y to hack into your code and change all of the X's to Y's and magically win. This is a way to prevent that. We make it final. Once I set a name, that particular player's name is not going to be able to change. Just like before, I'm going to have this getter statement to get my name. That way we allow the player to be in control over who gets their name. And I'm also going to need one of these constructor things that we talked about. So what I'm going to do here is this is a constructor. Notice the constructor has the exact same name as the class. That has to be that way. So the instructor has the exact same name as the class. And I bring in a name. When I create this player, I'm going to bring in a name. And then I'm going to make sure that this is the name of that player. That's what this statement right here does. We take the name we bring in and we assign it to the player. So this is a player. Players are going to have pieces. So let's go take a look at our pieces next. Now, our pieces are going to be kind of interesting. Our pieces, well, each piece is going to have a name, the player it's associated with. And one way we can do that in Java is we can say what's called extends. What this is going to do is this is going to say, okay, everything that a player has is going to be inherited by a piece. So anything we put in player is going to become part of a piece as well. And this is a way in Java and in any object-oriented language, this is called inheritance. And this is a way to separate different types of data into different classes. So the player's name really goes with the player, but the piece needs to know it too. So one of the ways we can model that is by using this extends, meaning everything from player is going to become part of pieces. So a piece then, because it's inherited from player, already has a name that's inside a player. What I want to worry about then is the things that are specific to a piece. And a piece exists somewhere on the game board in a specific row and column. So when I create a piece, so if I'm ready to place a piece on the game board, what I need to know is the name of the player it's associated with, what row it's going to go to, and what column it's going to go to. And so that's going to be the constructor for a piece. When I go to create a piece, I have to send it the name of the player, the row, and the column. Now, we know about how to handle the row and the column. I want to go back for just a second and look at player. Player has a constructor that allows us to send it a name and allows us to make a name for it, right? Player already has that built in. So I'm not going to rewrite that code. I'm just going to use it. So I'm going to call super. That's the parent, or what's called the super class, the one that pieces is inheriting from. So we like to think of player as being like the parent and pieces of being a child, are a superclass and a subclass. So I'm going to call super, and I'm just going to send it the name. And now that's going to allow us to put a name in for this piece as well. And we're going to do those getters and setters. Sorry, we're going to do those getters just like we did for the other instance variables that we set up. Java's been around so long and there's been so many of us working on it that these instance variables go by a lot of different names depending on who you talk to. Instance variables is one of the more popular names, but you'll also hear them referred to as fields. You'll also hear them referred to as attributes. Because, you know, if we not confusing enough, we're going to give multiple names to things. Now, Java's just, it's been around for so long and there's been so much good work done with it that you will see quite often that in Java, things will have multiple ways of doing things, multiple names for something. And so it's just one of those, you know, idiosyncrasies of the language that you're going to have to learn as you learn the language. I want to do one other thing here. There's going to be a time when I want to print out a piece. Well, what's going to happen with these pieces is they're going to become a blob of data inside of our computer. Well, printing out a blob of data is not really useful to people. We don't really see ones and zeros and this all mismatch of stuff very well. So what I want to do is I want to make sure that when I print this out, when I print out a piece, I want to be able to see the data that's in the piece. I want to be able to see the name, the row, and the column. I don't want to just see a blob of memory. So if I don't do this, what actually gets printed out is this hexadecimal code that really means very little. So what I'm going to do is I'm going to come down here and I'm going to create this another method. It's just another method like the other methods we've created. But this time, what it's going to do is it's going to allow us to print out the name of the player. By the way, I'm concatenating strings together with the plus sign, and that's something you're allowed to do in Java, is if you want to put strings together, because remember, get name from player, get name, it actually returns a character, which is part of a string. So get name, we have a string, what's called a string literal here, because it's actually something I've typed in. Then I'm going to have another string literal, because ultimately what I want to do is I want this to print out something that looks like this. Put a little comment in here so I can show you what I want this to look like. So that'll tell me that this piece is from player Y on row 1, column 2. That's ultimately what I'm trying to print out here. So let's do a get row. And then we're going to have a comma here. And then we're going to have a get column. And then we're going to need that closing square bracket. And I think we're good. So this is just a way, if you want to print out a nice representation of our object, you use this toString method. And we're going to use it in a few minutes. So we all started with this. We decided to figure out what a piece was because we were going to print the game board. And when we printed the game board, we were going to have to print out a piece. That was kind of the whole point of why we decided to switch over and work on what a piece was. But because we knew what a piece was, we also had to work on what a player is. Well, now let's go back and look at board. Now, we can fancy this up a whole bunch as we go along, but let's just try to get this printed out first. Let's just try to get something to show up on the screen. So one of the things we can do is we could go through a loop here. Let's create a loop. What I'm going to do is I'm going to tell Java that I want to loop through my rows. Okay, so I want it to loop through my rows. Now, interesting thing about the way programmers count. When programmers count, they start at 0. I mean, there are technical reasons why that's the case, but you just have to keep in mind that programmers like to start counting at 0. So the first row on our tic-tac-toe board is going to be row 0. The second row will be row 1, and the third row will be row 2. You know, if it wasn't confusing enough, then let's throw something else at you, is that we're going to start counting with 0. Okay. Well, you know, deal with it is probably the best thing I can tell you at this point. Okay, so what I'm going to do is I'm going to do this loop. And inside of this loop, I'm going to come down here and I'm going to print from my game board. I'm going to print the name of my piece. Now, remember, this is a piece. Get name is nowhere inside of pieces, but it is inside of player. So because pieces is a child of player, it could use everything that player has. And one of the things that player has is get name. So and I want to throw something out here at this point. So we've been programming now for about 40-ish minutes or so, and everything is going well. Okay? It's all flowing. I've got all my instance variables showing up. I created a nice list of classes that we need. In a minute, we're going to go fill in main and we'll get nice objects created and it's all going to work. That's not programming. Okay. I just want to throw that out. I'll give you an analogy. I also used to be a math teacher. And one of the things that most of us have run into in math classes is you go into the math class and the teacher works out this beautiful problem and everything flows beautifully. And then you go to look at the problem and you're like, I have no idea what's going on. When I first started this tic-tac-toe game, that's the first thing that came to my mind was I have no idea what's going on. And so keep in mind that if you go to attack a programming problem, your code is not going to flow as easy as what I'm showing you today. This is a real condensed version. So imagine if you were going to create this, it taking you a day or two to create it, as opposed to an hour or so for me to present it. So that's just one thing. The other thing I want to point out is if I keep looking off to the side and I have all the code already written. So this is all, I never code without having some sort of sample code up. And I've already have all this code written, so I know I'm going to get it right when I'm presenting it to you. So just keep that in mind. You're not seeing me struggle doing this. You will. And so did I. You know, you didn't see the struggles that I went through to come up with this code. So I just wanted to point that out, that even though I'm going to tell you right now, well, what happens if we don't have a piece there? How do we know what its name is? Well, I just happen to know what to do because I've already thought it through and worked it out and tested it. So one of the issues that we run into is this. What if we don't have a piece? Well, we won't then have a name to print out. So here's what I'm going to do. I'm going to come in here and I'm going to say, if I look at this particular spot in the game board and there's no piece placed there, and in Java, that's going to say that it's a null. What I want to do then is I don't have a name. So what am I going to do? Well, what I want to do is I want to actually print out nothing, just a space instead of the name. Now, if I do have a name, then what I want to do is print to the console, and this system.out.print is how you print something to the console. I want to print to the console the name of my player. So if I don't have a piece there, then I don't have a name, so I'm just going to print out a blank. But I want to, if I do have a piece there, I want to actually print out the name. And then at the end of printing a row, because that's what this nested for loop does, is it prints out a row. After doing that, I want to make sure that I start the next row on its own line. So I'm going to do a print line. That means start the next one on the next line. So now we have a way to print the board. All right, let's look at a few other things that we can do. Well, actually, let's stop right here and let's go look at our main. We've kind of left this alone. I said this was the entry point. This is how we would get our application started. And every Java program out there, whether it's running on your small little medical device or running on some huge web server, all of them start out with something called a public static void main, and they take in an array of arguments. Every Java program out there has one of these, and that's where we will start our application. This is the thing that gets us started. Well, to get us started, I need to create 2 players. So I'm going to create a player 1. That's, I don't know, how about X? That sounds good. And player 2 will be Y. All right, I now have 2 players. I also am going to need a board. I'm going to need a board to play on. So what I'm going to do is I'm going to create a board. I'm going to create a board that I'm going to call game board. And when I create this board, I'm going to call that method that we created, that constructor that we created in board, and I'm going to send it the rows and columns. And that's going to create a board for me. After I create this board, I want to print it. Now, if I ran this right now, which I could do, you're not going to see a whole lot. Actually, I'm going to come back and make a little bit of a change so we can see something. Instead of printing just a space, I'm going to have it print a Z. So that way we'll be able to see something. So let's see where we are right now. We've set up a lot of things, but we haven't actually started playing the game. We're going to get to that in just a minute. Now, one of the things you'll notice in Java is that there's a lot of effort that's gone into setting things up, which is what we've done. But then we have to go in and, but now that we have it set up, we could create as many games as we wanted to. So a lot of effort at the beginning, but then as we go and want to play multiple games, well, it's all set up for us. All right, I'm going to come over here and I'm going to compile. Clicking that compile button does that thing of taking it from the code that I just wrote and putting it into that bytecode that we talked about. And now I'm going to come over here and I'm going to say to run my program. And I come up with a tic-tac-toe board of all Z's. That is not very exciting. Let's do a couple things here. Let's talk about how we could set up an autoplay feature first, and then how we can see if we have a winner or not. All right, so I'm going to close out of this. I'm going to come back over here to board. So under board, I'm going to create a way to auto play. Well, first of all, I need to decide what do we mean by play. So I'm going to create a way to play a piece. Here's what I'm going to do. I'm going to create a method inside of my board that's going to allow us to play a piece. And what I need to send it is the player that's going to be making the play, the row where we want to play, and the column where we want to play. So we can find the specific spot on the board where we want to make the play. Well, one of the things I have to do if I'm going to make a play is I have to determine if a space is free or not. Well, I have a method that I wrote that's going to allow us to do that. And I've spent some time talking about methods, so I'm going to spend some time kind of finishing out this tic-tac-toe game, but I'm going to be cutting and pasting some code that I've already written. But I just want to show you what's going on here. So what I do here inside of is space free, I'm going to check using an if statement. I'm going to check to make sure that where they're trying to play, the row and column where they're trying to put the board, is actually on the board. Because if it's not on the board, I'm going to assume the space isn't free, right? Because it's not on the board. Then I check. So if that's the case, I just stop right there and I say it's not free. So I can't play there. I'm going to come down here and use what is called an if-else statement. And I'm going to look at my game board and I'm going to say, is there a piece there? And we've already talked about that when we were printing. Is there a piece there? If there is not a piece there, so it's empty, I'm going to say, sure, space is free. Otherwise, space is false and you can't play there. So to play is fairly straightforward. Ignore that line. So what happens is, can I make a play? So I send it a player, a row, and an integer. I check to see if I can make a play. If I can, great. I create a new piece and I put it at that spot in the board. And I return true. Yes, I could make a play. Or I return false. I don't do anything and I just return false, meaning I couldn't make the play. That's it. That's all we have to do to make a play. Now, if I wanted to do an auto play, so I just wanted to set this up and I was just going to let this run and I'm just going to have my players play themselves. This is an interesting method. So with this method, what I'm going to do is I'm going to go through and it's really simplistic. It's going to go through and it's going to find the first available spot on the board, and that's where it's going to play the piece. Obviously, that's not a very good method. That's not a very good algorithm on how to play this. So what I want to do, what I would really want to do is I would want to take this method right here, and I would want to have some external data science, machine learning algorithm, some database, something that would tell me the best place to play. And so this is how like the back end then ties into Java. You're writing all this Java code and then poof, you get to a spot where you either need help, data, algorithm, something from an external source. You reach out and you grab it and bring it in. But that's why learning Java is so important, is because most of the work that you're going to do is going to be inside of Java and manipulating these Java objects. And then, yes, you'll need to bring in things from the database or bring in things from a machine learning algorithm or something like that. But that's going to be a small part, very important part. But it's going to be a part you bring it in and then you're going to work with Java. So that autoplay that I just threw in there, that's all it's going to do with this case is it's just going to go out and find, the first available spot. But when I want to enhance my autoplay, I just replace what goes inside of this code right here. It doesn't affect the rest of my program. The rest of my program is going to work exactly the same. Now, one thing we're going to have to determine is whether we have a winner or not. And I'm going to drop in a lot of complicated looking code about how we determine if we have a winner. And this is something that, as you learn Java, you would learn a whole lot more about. But first of all, I dropped this code in and you'll see immediately that there are things that say this doesn't work. Well, that actually does. Java relies on Java has a lot of things built into it. So far, the things we've been using are all built into Java, but it also relies on a lot of external libraries. And so sometimes you'll try to use something that's in one of these external libraries. And to do that, I need to import the library. It's not a big deal, but I do have to come up here and manually import the library. And how did I know which library to import? Well, I've already looked it up, but typically what happens, I know this isn't a very scientific approach, but typically what happens with me is I'll use a command, I'll realize that I need an import, I'll go out to Google and look up what the import is. That is usually what ends up happening. And so you'll see that these arrays now are no longer have little squiggly lines under them, meaning that they're working now. Now, I want to do one other thing. I'm going to come up here to edit, and I'm going to go down to auto layout, and that's going to shift a bunch of my code around to make it a little more readable. So like I said, this is some complicated code, but what I wanted to point out is Java has these things called streams. They're a data structure that's built into Java that is in a very efficient way of handling large amount of data. They're a little bit of an overkill for this small tic-tac-toe board, but I put them in here because I wanted to talk about these are some things you would be using a lot with like a back-end system. So yes, we're modeling what you would do, and you would, instead of pulling this from the game board, you might pull this from a list of customers that you have, and you may want to find out, do a distinct count of your number of customers. Maybe you're pulling in orders and you want to count how many orders you've had or something like that. But the nice things about these streams is that they work with just about any other type of data that you'll have in Java. They can work with large amounts of data. You can split them. You can have streams in parallel, so they're making use of multiple processors on your computer. You can also set up one of these streams to continuously bring in data. So like if you're reading some data from a network and you have no idea how long it's going to be, maybe it's just going to be a few bytes. Maybe it's going to continue forever. You have just a constant feed you're getting from the stock market and you're wanting to do some sort of average with it. Well, that's what these streams are for. They can work with large amounts of data. They can work with continuous data. Really helpful data structures in Java. And so I just wanted to throw in the use of them to help me determine the winner. There is one more thing that I have to be able to figure out, that I have to have the board be able to figure out before I can go forward. And that is, I have to be able to have it determine whether there's actual space available on the board or not. So I have a way to make a play and I can see if the play is going to be, if it can play at that spot. But how do I know if we can make a play at all? Well, I'm going to create a method called space available that returns a true if space is available. Otherwise, it returns a false. And with this, again, I'm making use of this stream idea. So I take my entire board and all in one pass, I search the board to see if anything is equal to null, meaning that there's not a piece there. And this does all the board at once. And it checks to see if anything's null. And if it is, great, I have space available. If not, I'm out of luck. I can't play. Now, I've been working, and like I said, this is where I really fall into, I spent a lot of time on this, kind of thing. I'm going to replace our print board. All I'm going to do is, we have a print board. It works okay, but we can get a whole lot fancier. So I'm just going to come in here. And like I said, sometimes you just want to replace an entire method with something new. It's not going to affect anything else that is going on. And there we go. So I've just replaced our board is what I've done to make it fancier. But again, and that's just, you can, and you'll be doing this a lot in Java programming, is you can take just these methods and replace them with something that is more enhanced, but it doesn't affect the rest of your code. So this code then is encapsulated. What happens inside of the board is all inside of the board. And so you can update how the board is doing something without affecting the rest of the play. Let me show you what I mean by that. I'm going to come back over here and I'm going to compile everything again. And I'm going to get a board. And now when I've printed the board, you'll see I have something that's a whole lot fancier. And I had forgotten to clear my previous one. That's a BlueJ thing. And see, now I have a board that's a lot fancier. I want to do one more of these big just replace things. So ultimately, what we want to be able to do, of course, is to play tic-tac-toe. And so we have our player, we have our board, and what I want to do is I want to be able to do this. And I'm just going to kind of drop some code in on us. Again, just to give you an idea of something that you can do. So this is a lot. This is a lot that I just dropped in, and I'll show you what I just dropped in here. But I realize that this is a lot just to drop on here. But it's something that, as you continue your Java studies, you'll learn about how to do these things. But what this does is this now takes advantage of all of those methods that we put inside of a board to allow us to play a game. And what I'm going to do here, I'm just going to go make a couple of little more changes that's going to allow us to take input from the screen, make a play, and then have the computer use that autoplay feature to make its play. So here's what I want to do. I need to do a couple of things here. First of all, I have some imports that I just have one import I'm going to need for right now. And a scanner is something that allows us to read in things from the keyboard, from the console. All right. So what we're going to do is player one is going to be able to make a play, to manually make a play. So player one, if we're at player one, we're going to check to see if we have a space on the board. If we do, we're going to read in the row and column. And then it's going to play that row and column if it can. If it can't, we're going to keep looping, asking for a row and a column until they actually play a good one. And then if it's player two, we're going to run the autoplay. And if we go through here and we actually have playing done, then we're going to check to see if we have a winner. After each good play that we have, we're going to check to see if we have a winner. If we do, that's great. If not, we're going to switch to the other player. That's what all this is going to do. If we can't play at all, then we're just going to stop and say we don't have a winner. Something's wrong and we can't get a winner. So let's see what this finally ends up looking like. So let's compile. And let's come over here and let's run this. Now, this is not the fancy... Oh, I need to clear this. This is not the fanciest thing in the world, of course, but it's going to do its job. One thing to keep in mind is that if you do go into back-end development, you're not going to be producing anything really fancy. Let's do an input here. Let's play at row 1, column 1. Let's put a play right there. And so I put a play right there, right? And then the game waited for a second and put a play right there. I'm going to go fix something in my code. I'm not happy with this. We'll come back to this. I want to do a little something over here with my code. I want to come over here to board. And I'm going to put in what's a very special BlueJ command. So this just works with this IDE. And I try to avoid commands that are specific to the IDE, but in this case, I think it's going to make it a lot easier for us to read. What I'm going to do is I'm going to do a clear screen before I print the board. And like I said, this particular way of doing a clear screen is specific to this IDE. But I think it's going to make things a lot easier for us. All right, let's try this again. All right, so it's going to ask us now for a row and a column. Let's do that 1, 1 again, just like we did before. It places the X, and then it places the Y. And the only difference is here, I'm still just redisplaying everything like I was before, but I'm clearing the screen first. So let's do a 1 and a 2. Oh, I can't do 1 and 2 because row 1, column 2 already has something there. So let me do a 2 and a 1. Ah, there we go. And then let me do a 3 and a 1. And I have a winner. Now, I don't have the code set up to print out that we have a winner, but I have a winner. So, again, just to kind of wrap up, the point of this was to kind of show you what's possible in Java. There was an awful lot that we covered here today. And so where you would go from here is you could now see kind of where you would be headed with writing a Java program. Now, what your next steps would be to go in and figure out, okay, so what do all these commands mean again? And how do I write one on my own? In the description of the YouTube video, there is a link to this code that I've written right here. It has a couple of little additions to it than what we talked about today, so you can learn a little bit more by looking through the code, and feel free to go use it, play with it, and whatever. So that is... So that is what I had to talk about today. And again, to let you know, my name is John Mitchell. I'm one of the Java instructors here at Lambda School. And if you're interested in learning Java, it's a good place to come learn. So keep a lookout. We have a back-end program that's going to be starting in the fall that we're actually starting to advertise now that is really helpful and is really, really a good thing. So if you're interested at all, do take a look and reach out to us. But by the way, I would be selling it, and I did sell Lambda School before I worked here. So anyway, that's what I wanted to say. I hope you enjoyed this, and do come back, and you can always reach out to us at Lambda School. If you have any questions, you can comment on the GitHub link that's out there. So keep studying. Keep working. It's worth it. It's hard, but it's the hard that makes it good. So thank you for your time, and I hope to see you someday at Lambda School.